How you doing? We are still in section 1.3. This is the part 2 video where we're going to start with the last half of what we need to do for example 4. So here with example 4, we're asked to check our solution. And so when we check our solution, we take the answer and we plug it back into the original equation and make sure it's all good. So I'm going to do exactly that. I start off with my original equation, which is a plus 4.39 is equal to 76. There we go. Let's make that a 76. And I'm going to plug this value in for A. So since A is supposedly equal to 71.61, I'm going to plug that in and see if it all works out. Technically, there's kind of like a question mark here. I'm like wondering, will it all work out? And so when I add 71.61 to 4.39, I see that good things start to go. 0, carry 1. Oh yeah, 76, 0, 0, woohoo. So I feel good about it and my check is good to go. I'm going to do a similar thing over here. When I check, I'm going to take the answer for D, D being negative 30, plug it back in and hope all works. So over here I've got negative 3 over 5 times negative 30. And that should be equal to 18. What I'll do is I can multiply top and then divide by 5, but I'm being a little lazy and I want to cross cancel. So when I do that, I know that 5 goes into itself one time, 5 goes into a negative 30, negative 6 times. So negative 3 times negative 6 is going to be a positive 18, and woohoo! If I were thinking about this with a question mark, the question no more. Certainly 18 is equal to itself. And so I'm feeling pretty good about myself. So remember that when you check, and here's our check right here and our check right here, you're plugging in the original answer or the answer you got into the original equation and making sure everything works. Here at example 5, we are solving a multi-step equation. With multi-step equations, I kind of have a set of rules that I like to think about. The first rule is to simplify each side of the equation. Each side. So we're going to make it as simple as possible. Well, the fortunate thing for us is that 22 cannot get any simpler. So I'm going to leave that 22 there. It's going to come along for the ride. But over here, I can do some work. And what I need to do is the distributive property. So I'm going to distribute this positive 2 through the parentheses because I need to free myself of parentheses so I can join some like terms. And then I'm going to distribute this, not 3, but negative 3. When I see a minus 3, I recognize it as negative 3 because remember the keep, change business that we did before? I don't actually always write that down, but if you need to write that down, you certainly can. But this lets me know that I'm actually dealing with a negative 3. So 2 times 2 gives me 4x plus 2 times 3, which is 6. Now negative 3 times 4 gives me a negative 12x, and a negative 3 times a negative 5 gives me a positive 15. All of this is equal to 22. Now I'm going to join some like terms together. And we remember joining like terms. We look for terms that are similar and common. So here, the ones that I've double underlined in red are called constants. They're just regular numbers. They are constantly going to be what they're going to be. They're not changing. And here, these are variable terms. So I've got a positive 4x and a negative 12x. When I bring those together, when I add a positive 4 and a negative 12, I'm going to get a negative 8x. And when I have a positive 6 and a positive 15, and I add those two bad boys together, I'm going to get a positive 21. And that's what this thing is equal to. All right. Now that I have that together, I am going to do some solving. And so what I do after I simplify each side, so this is as simple as this can get, and this is as simple as this can get. After I've done that, my next step is going to be to decide where I want my x terms or variable terms. Sometimes we're not using x, and constants. Okay. So what does that mean? So sometimes I legit will go and say, okay, x terms, I want you over here. Doesn't matter the side, but since the x terms are already here, I'm going to shift them over here. And then constant terms, I want you on this other side. And so what that does is I basically separate two different sides of my equation so I can push things around to where I want them to be. So in this case, this is a constant. 21 is a constant. So it needs to move to this other side. And this is an x term. It needs to stay put right over here. So in order to move this positive 21, I need to add its additive inverse. You guys are going to get tired of me saying that, additive inverse, but I got to add it to both sides, and that cancels that out. So it's like a plus 0 here. 22 plus a negative 21 is a positive 1. So basically 8x is equal to positive 1. Solving that bad boy, I'm going to divide both sides by 8. And I get that x is equal to 1 over 8. And did I do something wrong? Yes, I did. I missed the fact that it was negative. So I'm going to go throw some negatives in there. And now it's a positive 1 divided by a negative 8. And my answer is a negative 1/8. I don't like how that looks. So I'm going to erase it and make it look more better. So, but I hope you saw the process, right? So x is equal to a negative 1/8. And we did that by first simplifying each side, deciding where I want my x terms and my constants, the constant terms. Then the third thing we did is we moved stuff, right? We moved things to where they belong. And the final thing is we solved. And when I say we solved, basically that's usually going to be that we divided both sides by something. And this will lead you through many, many difficult problems. So keep these 4 steps in mind as you are working on some mathematics. All right, let's look. We got example 6. Solve for the variable. So this kind of an equation is called a literal equation, where you are solving for a variable, but you're not actually going to get a numerical answer. So here we have the surface area of a cone. And so it's kind of like if you wanted to think about wrapping this cone up in a sheer piece of plastic, you would need to know, and therefore you wanted to know how much plastic you needed or how much you needed to cover the surface area, you would use this formula, pi times r times L being the slant height of this particular cone, plus pi times r squared. And that's going to give you the area at the bottom and then the area along the sides. So here we have this beautiful formula. S is equal to pi r L plus pi r squared. And we are asked to solve the formula for L. This is a common thing you'll see in the SATs. You want to get L by herself. All right, so that means you got to get everything else away. L is way too stuck to pi and r here. So what I'm going to do is get rid of this guy first. So the fact is, I think of this like any equation. I need to get everything pushed over to the other side to leave L alone. But the first thing I'm going to do is get rid of the thing furthest away. So the thing furthest away is pi r squared. And so notice I'm going to add the additive inverse. I've done this before, right? I'm going to add the additive inverse. So if this is positive pi r squared, I'm going to do negative pi r squared. That's going to cancel that out. And on this side of the equation, on this left side, I can't really do anything. So I just have to leave it as s minus pi r squared. All right. So now that we have that, we've got pi r L. And still L is here, and we want to isolate L. But who's bothering L? Pi and R. How are they bothering L? By multiplication. What's the opposite of multiplication? Division. So I'm going to divide away my problem because that's the opposite of how it's bothering the L. So I cancel those guys out, and look, L is beautiful, pristine, and alone. And so that's what we wanted. L is equal to S minus pi r squared over pi r. Here's some tempting things. Wait a minute, there's a pi here and a pi here and an r here and an r here. Can I cancel them out? The answer is a deep and resounding no. The only way that you can cancel out when you have a sum or difference in the numerator is if you break down the fraction by separating the terms of the numerator and rewriting the denominator twice. So here, if you wanted to do some canceling, you could, because now the only thing this is one problem, and so yes, I can cancel the pi and cancel the pi and cancel the r and cancel one of the r's. So I'd have s over pi r minus r. This answer is equivalent to this answer, and that's the only way you can do canceling. You can't just go whoop whoop and get rid of it and say, okay, this is s minus r. Got me? I hope so. I know I was talking fast, but try to stay with me because that's a really important thing. Even my calculus students like to do some fancy, crazy canceling that doesn't make any sense. All right, so here we have example 7. Apply properties of equality. And so what this is giving us is the opportunity to kind of think through the properties of equality while we solve equations. And so here, this is very SAT-like, so I do want you to look at this. They said if you have this, 3n minus 8 is equal to 9 over 5. What is the value of 3n minus 3? And so there's like a temptation here to solve for n and then plug the value of n back into this equation, this expression rather, 3 times whatever n value is minus 3. That can work. But what I'd like you to do is think about how you can massage, manipulate, transform this side of the equation into the golden thing that we want. We wish this just said 3n minus 3 is equal to, and then we can figure out what it is. And so what would I have to do to this side in order to make 3n minus 8 into 3n minus 3? Well, to me, it looks like I'd have to simply add 5. Do you see that? If I were to add 5 to that, then negative 8 plus 5 is going to give me a negative 3. That's dope. So I'd have 3n minus 3, which is what I want. But we know in mathematics, you can't just walk around willy-nilly adding stuff where you feel like it. What you do to one side, you got to do to the other. So I'm going to add 5 to both sides. Are you walking down my street? I hope so. So when I add the 5 here, I get exactly what I want. Nice quick manipulation move. And when I add 5 here, I'm adding 5 over 1 plus 9 over 5. Let's common denominate that and make sure that we recognize that this is now 25 over 5 plus 9 over 5. And when I add those guys together, I get 34 over 5. Swoop delicious. Boom. I get that as the answer. There's a lot of different ways to approach standardized tests and multiple choice questions, considering that the answer was already here. The only problem in this one is that it's not as easy just to plug it in here, right? You can't plug this in for n because that's not what they're asking for. They're asking what 3n minus 3 is equal to. So as I mentioned before, we could have taken the original equation, 3n minus 8 over 9 is equal to 9/5, and worked it out and solved for n, right? If we had done that, I'm going to do some quick math here. If we had done that, we would have ended up with 49 over 5 is equal to 3n, and then divide both sides by 3, which really means multiplying by a third. We would have had 49 over 15. Not pretty, but then we would have taken that and shoved it back into this equation, and eventually we would have gotten 34/5. Lot of work, lot of time, not impossible, but you need to look for shortcuts when you're working with multiple choice test items. All right, let's see if we can get to this last. I think this is the last one. Yeah, last one, and then we'll look at our assignment. All right, so we've got Josh and Pam. They have an older home, and that needs some repair, and after budgeting a total of $1,685 for home improvements, they started to spend money. They spent $425 on small improvements, right? So after that, they decided they needed to replace 6 interior doors. What is the maximum amount of money they can afford to spend on each door? So as I look at this, I recognize this is how much they budgeted. This is how much they've already spent. And to think about how much they can spend on each door, if they spent all the rest of their money on each of the doors, on 6 doors, I'd have to divide by 6 to figure out the maximum amount of money that they can afford to spend on each door. And so when I do the subtraction here to solve this, I get 1,260 divided by 6 is going to give me the amount, or the maximum amount they could spend for each door. Dividing 6 into this number is pretty simple. 6 goes into 12 2 times, 6 goes into 1 time, and 6 goes into 0 times. So I realized that this is the maximum amount they could spend for each door if the doors were equally priced and if they decided to spend all of their money. And that's pretty much what we need to be able to do when we're looking at word problems and we're trying to solve them. We got to set up an equation. So that's what we got to do. Your homework or your assignment that I'm going to ask you to do is pages 24 and 25, numbers 19 through 63. Again, remember this is section 1-3. And since you're doing odd problems, this shouldn't be too bad. You're just knocking them all out. No tricky business here. I look forward to talking to you soon. Please let me know if you have any issues, and I'll happily answer any of your questions. Have a good one. Talk to you soon. Bye-bye.